Hello students, good morning. Today we are going to the fourth session of the same chapter, that is quadrilaterals. We already completed 3 sessions, right? In the first session we discussed about the polygons. In second session and third session we discussed about the some basic properties that related to quadrilaterals, right? For example, the angle sum property of the quadrilateral. The total interior angle of the quadrilateral is always equal to 360 degree, right? And we learned few more concepts. For example, adjacent sides and adjacent angles, opposite sides and opposite angles of the quadrilateral, okay? And we solved some numerical problems which is based on the angle sum property of the triangle, right? So in this session we are going to divide the quadrilateral. So how you can divide the quadrilateral? We already know the definition of quadrilateral. Quadrilateral means it is a polygon bounded by 4 line segments, or it has 4 sides, okay? So quadrilateral. This quadrilateral is basically classified as, first one is a parallelogram, right? Next, kite, parallelogram, kite. Next one, trapezium. Sometimes we are also called it as a trapezoid, right? So trapezium. This parallelogram again we are classifying as rectangle. Next, here rectangle, and one more is rhombus, and these two are square, right? This is the basic classification of the quadrilateral. How we are going to classify, on what basis we are classify the quadrilaterals? Listen here. Quadrilateral, as you already know, a quadrilateral is a polygon which is bounded by 4 sides and 4 angles, right? So parallelogram. What are the properties of parallelogram? Some basic properties we will discuss today, right? So in parallelogram, a parallelogram is a quadrilateral in that opposite sides are equal and parallel. For example, this is the parallelogram in that the opposite sides are equal and parallel to each other, right? Next, come to the second one, that is kite. In the kite, adjacent sides are equal. Right? Next one, trapezium. This trapezium again we are classified as a isosceles trapezium. So trapezium means what? A quadrilateral in which one pair of opposite sides are parallel, but they are not equal. They are just parallel only. Only one pair of opposite sides are parallel in the trapezium. Next, isosceles trapezium means what? Isosceles, we already discussed in the triangles. In the previous classes we already learned, right? So isosceles means 2 sides are equal. So isosceles trapezium means the one pair of opposite sides are parallel and remaining one pair is exactly equal. For example, here ABCD is a isosceles trapezium. In that AB is parallel to CD or DC. These two are the parallel sides. and remaining one more pair is there, no? So these two are the equal sides. It means AD is equal to BC. AD, the length of AD is equal to the length of BC. So in isosceles trapezium, one pair of opposite sides are parallel and another one pair is having equal length. So this is the isosceles trapezium. Next, come to the rectangle. We already learnt in the previous classes, right? So rectangle means what? A rectangle is a quadrilateral in which opposite sides are equal and parallel. Opposite sides are equal and parallel, and each angle in the rectangle is 90 degree. So each angle in the rectangle is 90 degree. Okay. Next, come to the rhombus. Rhombus is the quadrilateral in which all the four sides of the rhombus is equal. All the four sides of the rhombus are equal. Okay. Next one, come to the last, that is square. We already learnt in the previous year. Square means a quadrilateral in which all four sides are equal. All four sides are equal and each angle measures 90 degree. So this is the basic classification, right? So on the basis of some properties, we are classified the quadrilateral as a parallelogram, kite, trapezium. Again, that parallelogram is classified as a rectangle and rhombus. These two are nothing but a square. Okay. In the next classes, we will discuss more the properties of individual quadrilaterals. Okay. So that first one, take that first one is a parallelogram. So what are the properties of parallelogram? Consider the first quadrilateral, that is parallelogram. So as we already discussed, parallelogram is a quadrilateral in which opposite sides are equal and parallel. Is it parallelogram having only one property? No, it has so many of properties. Listen here. The first concept is parallelogram. Parallelogram. Okay. ABCD is a parallelogram. ABCD is a parallelogram. So how you can define the parallelogram? Parallelogram is a quadrilateral in which opposite sides are equal and parallel. The opposite sides are equal and parallel. Okay. Next one. So first property, what are the properties of parallelogram? Properties. We are discussing some basic properties that is related to the polygon, right? Opposite sides are equal and parallel. So what are the opposite sides? Opposite sides are equal and parallel. Equal and parallel. So simply we are representing a parallel lines as like this. So opposite sides are equal and parallel. So what are the two opposite sides here? AB is parallel to this line. AB is parallel to DC, and it is also equal. AB is equal to DC. This is the first pair of the parallel lines. One more pair is there here. AD is parallel to BC. AD is parallel to BC, and the length of AD is exactly equal to the length of the BC. So this is the first property, in that opposite sides are equal and parallel. Okay, let's come to the second property. In the parallelogram, opposite angles are equal. So what are the two opposite angles here? Angle A and angle C are one pair of opposite angle, Angle B and angle D. Angle B and angle D are the second pair of the opposite angles. So opposite angles are equal. Opposite angles are equal. So what are the two opposite angles? Angle A, which is always equal to angle C. This is the first pair. Now consider the second pair. Angle B is equal to angle D. So opposite angles are equal. This is the second property. Next, come to the third property. We already discussed in the previous class. When I draw the diagonal in the parallelogram, here BC is the diagonal. It divides the parallelogram into two equal triangles, and the two triangles are congruent. Congruent means they are having equal size and equal shape. So diagonal bisect parallelogram into two congruent triangles. Congruent means that any two geometrical shapes, any two geometrical figures which are same in size and shape. So that two figures are called as a congruent. So the diagonal of the parallelogram bisect the parallelogram into two equal parts, and the two triangles are congruent. So here in the diagram, BD is the diagonal. The diagonal divides the parallelogram ABCD into two triangles. What are the two triangles here? Triangle A, B, D. First triangle ABD is congruent to the triangle BCD. Triangle BCD. Is it where by drawing one diagonal we are getting two triangles, and these two triangles are congruent. Here one more diagonal we can draw, right? Just draw the diagonal from point A to C. When we draw the diagonal AC, again we get two triangles, and these two triangles is also congruent. So what are the two triangles here? Triangle ABC and triangle ADC. So totally, when two diagonals are intersect, we are getting four triangles, right? And these four triangles are congruent. What are second pair? By using the diagonal, this is the two triangles obtained by the diagonal. What is that first diagonal? BD. Next, second triangle ABC. Triangle ABC is congruent to triangle ACD. When these two triangles are congruent, when we draw the diagonal AC, right? So this is the third property of the parallelogram. Next, come to the fourth property of the parallelogram. What is that fourth property? We already learnt in the previous classes adjacent angles, right? So here adjacent angles, the sum of any two adjacent angles in the parallelogram is always supplementary. Supplementary means it is exactly equal to 180 degree. You can take any angles. In this parallelogram, four angles are there, no? So you can take any two adjacent angles. The angle should be in the adjacent only. So the sum of two adjacent angles is always equal to 180 degree. That angles is also called as consecutive angles. So what is that your fourth property? Adjacent angles. Adjacent angles are supplementary. Adjacent angles are supplementary. So what are how many pair of adjacent angles we are getting in the parallelogram? As we already discussed in the previous class, in the particular quadrilateral we are getting total four pair of the adjacent angles. and all 4 pair of the adjacent angles are supplementary. For example, if I take these two are the adjacent angles, usually adjacent angles are having common sides, right? So angle A plus angle B, angle A plus angle B is equal to 180 degree. Take one more pair, angle B plus angle C is equal to 180 degree. Next, third pair, angle C plus angle D is equal to 180 degree. Next one, angle D plus angle A, angle D plus angle A, which is also equal to 180 degree. So any two adjacent angles in the parallelogram is always supplementary. This is the fourth property of the parallelogram. Okay, next come to the fifth property. When we draw the two diagonals AC and BD, these two diagonals are intersect at one particular point. That point of intersection is considered as a O. When two diagonals are intersect in the parallelogram, the diagonals are bisect. The diagonals are bisect each other. It means the each diagonal divided into two equal parts when they are intersect at one particular point. For example, here AC and BD are the two diagonals that intersect at one particular point, that is a O. When it intersect, the diagonal is divided into two equal parts. So what are the two equal parts here? The first diagonal, in diagonal, what is that point? Diagonals bisect each other. The diagonals bisect each other. So from AC diagonal we are getting two equal bisection points or bisection line segments. What are that two line segments? OA is equal to OB. OA is equal to OC. Here AC is the diagonal, no? So if it is bisected means the two equal parts are OA and OC. OA and OC. Next, consider the second diagonal, that is BD. BD is the second diagonal. When it intersect the other diagonal, it is bisected into two equal parts. So what are the two equal parts? OB is equal to OD. OB is equal to OD. These two are bisection of the diagonal AC, and second diagonal in BD diagonal the two equal parts are OB and OD. So this is the fourth property of the parallelogram. Next, we already discussed each and every quadrilateral has 4 angles, 4 sides and 4 vertices. So that is the considered as the next property. This is all similar to the each and every quadrilateral, because every quadrilateral has 4 sides, 4 angles and 4 vertices. So these are the some basic properties that is related to the. We will discuss some theorems on the parallelograms. In that first one, the first theorem, we need to prove that opposite sides of the parallelogram are equal. Second one, opposite angles of the parallelogram are equal. Third one, when the diagonal drawn in the parallelogram, the diagonal divides the parallelogram into two congruent triangles. So first one, statement, that is opposite sides of parallelogram are equal. Next, second one, opposite angles of parallelogram are equal. Third one, diagonal bisect the parallelogram into two congruent triangles, into two congruent triangles. So these are the statements. Okay, take one diagram. Here ABCD is a parallelogram. This ABCD is a parallelogram. A, B, C and D are the four vertices of the parallelogram, right? Consider AC as a diagonal. AC as a diagonal, right? Next, first write the, whenever we are going to prove the given statements or given theorem, we need to write the step by step. So that first step is, first you have to write the statement of the theorem, next draw the necessary diagrams. Wherever it is necessary, draw the necessary diagram that is related to the given theorem. Next one, write the given part of the theorem. Next, what you are proving in that theorem, what you have to prove in the given theorem. Next, proof of the theorem, and the last statement is conclusion of the theorem, right? So these are the some steps when we are going to prove any theorem, right? So first one, given. What is the given part here? We already know that ABCD is parallelogram. ABCD is a parallelogram, right? This is given part. In that parallelogram means opposite sides are parallel. So what are the two opposite sides are parallel here? AB is parallel to, the side AB is parallel to DC, and one more pair is there, that is AD is parallel to BC. These two sides are parallel. Again the second pair, opposite sides are parallel. Next, what we need to prove here? We need to prove that the first statement, opposite sides of the parallelogram are equal. So opposite sides, what are the two opposite sides here? AB is equal to DC or CD, or one more pair, AD is equal to BC. This is the first proof what we need to prove in the given theorem. Next, second, opposite angles of the parallelogram are equal. We need to prove that the opposite angles of the parallelogram are equal. It means the opposite angles, angle A is equal to angle C, or one more pair, angle B, which is equal to angle D. Next, third one, diagonal bisect the parallelogram into two congruent triangles. So AC is a diagonal, means we need to prove that these two triangles are congruent. So triangle ABC is congruent to triangle ABC is congruent to triangle ACD. So these are the three statements we need to prove in the given theorem. Next, construction. Join A and join AC. That AC is a diagonal, or draw the diagonal from point A to C, right? Proof. First, when the diagonal divides the triangle, the parallelogram into two equal triangles. Consider that two triangles. So what are the two triangles here? Triangle ABC and triangle ACD. The second triangle is ACD. In that we are taking here angle 1, this is, and this one is the angle 2, angle 3, this is angle 4. Or you can also take it as a X, Y, Z, A, or MNOP, right? So it is just our notation to the particular angles. We are denoting by the numbers here. This is angle 1, this is angle 2, angle 3 and angle 4. Instead of these numbers, you can also take the some alphabetical letters like M, N, O, P, right? In this, we are considering here two triangles, triangle ABC and triangle ACD. If these two are the parallel sides, in parallelogram, opposite sides are parallel. Whenever the two lines are exactly parallel, the angles formed in the parallelogram or the angles formed between the parallel sides are alternate angles, alternate interior angles or alternate angles. So alternate angles are always equal, right? So here in these two triangles, consider one by one. Angle 1 is equal to angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Reason? Because AB is parallel to CD, or you can also write it as these two are the alternate angles. Write any one reason. Either you can write AB is parallel to CD, AB is parallel to CD, or these two are alternate angles. Next, here AC is the common diagonal or AC is the common side for both two triangles. So AC is equal to AC. Reason? Common side, right? Next, one more pair of alternate angles are there here. So in first pair we are considering already angle 1 and angle 2. If these two are AD is parallel to BC, means we are getting one more pair of the alternate angles, that is angle 3 and angle 4. Angle 3 which is equal to angle 4. These two are the alternate angles, right? Therefore, triangle ABC is congruent to triangle ABC is congruent to triangle ACD by using the congruence property. Yes, yes. Say yes, is it? Here you are considering two angles and one side, means it is not a yes, yes. So by using the congruence criteria yes, here two angles and one sides are given, or we are considering two angles and one side. So two angles and one side, by using the ASA criteria, the given two triangles are said to be congruent, right? In the previous classes we already learnt, if two triangles are congruent, then their remaining part of the triangles are equal by using CPCT. Here CPCT means corresponding parts of the congruent triangle. It means if we proved two triangles are congruent, then the remaining part of all angles and all sides are equal. Therefore, these two are the congruent triangles. No, AD is equal to BC. AD is equal to BC. Next, one more pair, AB is equal to DC, right? Next, by using CPCT, and we are easily getting one angle here. Angle B is exactly equal to angle D. Angle B is equal to angle D. Angle B is equal to angle D. This is also by using the CPCT, the corresponding parts of the congruent triangles. Here we already proved the opposite sides are equal. So these two are the opposite sides are equal. Next, opposite angles are equal. We proved here one pair of opposite angles are equal. We need to prove one more pair, that is by considering these two angles. Just consider the two angles we are already taken in the first section here, right? While we are proving these two triangles are equal, we are taking two triangles. Similarly, consider that one. Angle 1 is equal to angle 2. Angle 4 is equal to angle 3. This is considered as equation 1 and equation 2. Now add equation 1 and 2. Add equation 1 and 2. What we will get by adding these two equations? Angle 1 plus angle 4, that is equal to angle 2 plus angle 3. Just observe the given diagram. By adding angle 1 and angle 4, we get the complete angle, that is angle A, right? By adding angle 2 and angle 3, we are getting one complete angle, that is angle C. So angle A is equal to angle C. So this is the proof of the given statement. What are the given statement? Let me check one by one. First one, opposite sides of the parallelogram are equal. Here, in first session we already proved the two triangles are congruent. The two triangles are congruent. If these two triangles are congruent, their corresponding sides and corresponding angles are equal. So by using the CPCT, we already proved here the opposite sides AD and BC, AB and DC are opposite sides and they have equal length, right? Next, here we already proved angle B is equal to angle D by using CPCT, and by considering the two alternate interior angles of the parallelogram, we proved one more pair of the parallelogram, one more pair of the opposite angles are equal, that is angle A and angle C. Angle A which is equal to angle C. So this is the complete proof of the given theorem. Hence we proved the given statements. Okay, so next take one more theorem, that is again on the basis of the parallelogram only. What is that theorem? The diagonals, when the diagonal bisect, the diagonals of the parallelogram bisect each other. The diagonals of the parallelogram bisect each other. The statement of the theorem is the diagonals of the parallelogram bisect each other. Right, the statement. The diagonals of the parallelogram bisect each other. We already discussed in the properties of parallelogram. What we discussed? When the two diagonals are intersect at one particular point, the two diagonals are equally divided into two equal parts, right? We already discussed it in the properties, no? So we will prove the given statement. For this statement, we need to draw one parallelogram first. Take one parallelogram. ABCD is a parallelogram. ABCD is a parallelogram. In that, I am taking two diagonals. AC and BD are the two diagonals, and these two diagonals are intersect at point O. Okay. So write the first given part of the statement. What is that given part? Given ABCD is a parallelogram. ABCD is parallelogram. If ABCD is a parallelogram, means opposite sides are equal and parallel. So here AB is parallel to DC, and these two sides are parallel as well as equal. So AB is parallel to DC. AB is parallel to DC. AB is equal to DC. One more pair is there, that is AD is parallel to BC. If these two are parallel sides of the parallelogram, then they are having same equal length. So AD is equal to BC. AD is equal to BC. So this is the given part of the statement. Next, what you have to prove in the given theorem? You need to prove that the diagonals are bisect each other. Bisect each other means it divides into two equal parts. So we proved here OA in diagonal AC, OA is equal to OC. OA is equal to OC, and one more, OB is equal to OD. These two we will prove by the two diagonals, by considering two diagonals. Okay. Next, construction. Draw diagonals AC and BD. Draw diagonals AC and BD meet at point O, or can also say the two diagonals are intersect at point O. Okay, let's start proving the given statement. Listen here. We already proved in the previous theorem, when one diagonal is drawn in the parallelogram, it divides the parallelogram into two triangles, and that two triangles are congruent to each other, right? Here we are taking two diagonals, AC and BD are the two diagonals, and when we draw the two diagonals in the parallelogram, we are getting four triangles. Here four triangles, you are observing four triangles are there. First triangle OAB, OBC, third one OCD, ODA are the four triangles of the parallelogram, right? So consider any two triangles that should be in the opposite sides. So in triangle, when we are considering any two triangles, it should be lies in the opposite sides. So triangle AOB, in triangle AOB and triangle COD, in triangle AOB and triangle COD, AB is equal to CD. AB is equal to CD. This is we already know, because ABCD is a parallelogram and this is the given part of the statement. Next, if AB is parallel to CD means here we are getting two alternate angles. Angle BAO, angle BAO. Angle BAO is equal to angle DCO. DCO, reason alternate angles. How you can identify the alternate angles? When two lines are parallel, the angle is in the shape of Z. So these type of the angles which are in the shape of the Z alphabetical letters are alternate angles, and that angles are equal. Okay. Next, one more pair alternate angles are there here. Second pair, angle ABO, angle ABO is equal to angle CDO, angle CDO. Again, these two are alternate angles. Now here we are having three elements are equal, means we can easily prove that the given two triangles are congruent. So triangle, therefore the triangle AOB is congruent to triangle COD. By using the congruence criteria, here we are considering two angles and one side. So angle, side, angle, that is ASA. Right? By using the ASA criteria, we proved the given two triangles are congruent. Once we prove the two triangles are congruent, then their remaining all sides and all angles are equal by using CPCT. So what are the remaining parts here? The sides, we are already considering one side of the triangle, no? That is AB and DC. Other two remaining sides, OA is equal to OA is equal to OC. Next, OB is equal to OD by using CPCT, corresponding parts of the congruent triangles. So here we proved when two diagonals intersect each other in the parallelogram, they are bisect. The given statement, the diagonals of the parallelogram bisect each other. Here we already proved, right? So this is the second theorem based on parallelogram. Okay.